the two-day national conference on electric vehicle charging infrastructure, day 2. Participants are ready. Dr. N. Stalin, sir, the examiner for the day session, for the post-lunch session. Sir, are you ready, sir? Stalin, sir? Dr. N. Stalin, sir?
Yeah, please proceed, sir.
Sir, with your permission, I would like to start the session. The first presentation would be Mr. Praveen Kumar Reddy and team, sir. Praveen, sir,
Yeah, sir. Good afternoon, sir.
sir, please share your screen.
Sir, yes. Sir, is it okay, sir? Is my studies are visible to you?
Sir, it is visible, sir. Please put this presentation on the full screen, sir.
Right. Is it
Yeah,
okay,
okay.
sir?
Yes, sir. Please carry on, sir.
Very good afternoon to all of you. And convener and the coordinators of this ICT sponsored two-day nation conference on electrical vehicle charging infrastructure. So, and also very good afternoon to Stalin, sir, who is the judge for this session. And so I am the co-author of this paper titled Location and Dynamic Management of EV Charging Station using ZW, Gray Wolf Algorithm Optimization Method. And the main authors are Dr. R. Sarvana and Dr. S. Suryaprabha and myself, Praveen Kumar Reddy. All are working as a associate and professors and assistant professor of CBIT, Deputy Department. Right, thank you. So coming to my paper, so location and dynamic management of EV charging station in Gray Wolf optimization technique. So today EV is the cutting edge technology. So almost all the combustible vehicles, IC vehicles are, are changing with electrical vehicles. And the major problem of using these electrical vehicles is how effective we can able to do charge, and what about that where we need to locate, and what about the dynamic management issues that can be raised for the charging stations, just like our normal petrol pumps and all. So, we have done some research survey, and we have used some methods where, and we came to know which is the best possible solution for establishing an EV charging station. And coming for this, you all know electrical vehicle should be charged by electricity. And nowadays, it is very easy for us to get electricity from renewable energy resources also, like solar, wind, and all. So EV charging station can be, can be given power supply either directly from the electricity department, or we can also get from renewable energy resources like solar. We can power that EV station itself with the help of solar and like wind, some renewable energy resources. And coming for this, so the architecture for minimum architecture required for setting up an EV charging station is, so hardware, we need a charger, and a software where we should take care of central management system. It may be a mobile app, and a service maintenance of charging stations and other hardware and software related issues. So if you go through this one, see this one, there is some central management system to mobile app is connected, which communicator to help locate the charging station reservations and billing details and charge status. Billing details in the sense, so normally if you go for a petrol pump, they will charge per liter, diesel per this much per liter, and like the cost of the diesel in terms of rupees or dollars. The same way here, we are about to charge our vehicle in terms of kilowatts and all. So they will charge maybe in terms of rupees, maybe hours, hourly basis, or dollars in terms of hourly basis. So next one, and segmentation of EV charging infrastructure. So types of charging, maybe battery swapping, and slow AC charging is there, and fast AC charging, fast DC charging is there. So if you go for battery swapping, so alternatively we should purchase one more battery. So without wasting the time, one will be in use in the vehicle, another will be in the at the charging port. And in use, commercial, it may be public home, and the components are we are using either software and hardware services. So where we can able to locate, we can use in cities, highways, and now we can also the EVs where in India. So this is the upcoming segment where in the recent couple of months or couple of years, we have seen the drastic improvisation of using EVs, both in terms of two-wheelers and four-wheelers. Even recently, some of the major companies like Tata, Hyundai, Honda, these companies are introducing cargo vehicles also in the segment, in this EV segmentation. So this is the central government scheme, FAME 1 and FAME 2. So to get the faster adoption and manufacturing of EVs in India. So this is about the scheme implemented for four main areas are demand creation, demand and EV creation, what about the technology platform you are using, and some pilot projects and charging infrastructure. They are looking about charging infrastructure. And next, this is about some graphical content about EV stations established as per FAME 1 scheme and FAME 2 scheme. So, number of EV stations which are located. So, based on that, state-wise. And coming to our main content for our, title, location and dynamic management of EV charging station by using this gray wolf optimization. So earlier, not only gray wolf optimization, we can having particles from PSO, uh, whale, even we can whale optimization. So different solutions we can able to get. So why we have choose this one, gray wolf optimization means. So we are aware of this one. Gray wolf means wolf. They are meant for fighting. They are meant for hunting. They can hunt in terms of like groups. So here, so if you go through this gray wolf technology, so it is like a meta heuristic. Heuristic in the sense, it is a problem dependent. So we can get optimization using problem dependent. And this GW, Gray Wolf optimization algorithm is based on meta heuristic property. So where the problem is independent. The problem is independent, and we can expect a high level problem independent algorithm. And this is a framework which developed optimization algorithm. And this is an set of guidelines or strategies. We can go with a set of guidelines or control strategies to develop a heuristic optimization algorithm. So this is the best. This will give the best solution. This will give the best solution compared with other optimization techniques. And so basically, the EV charging station. The use of this EV charging station depends on the type of the vehicle they are going for. The type of the vehicle in the sense, so for slow charging stations where we can use the vehicle only for a shorter distances, and we won't worry about the charging time and all. Another for extremely long explorers who will go some hundreds of kilometers, so they need quick charging without wasting their time. So this is very important. This is the challenging point today we are facing for quick charging and all. For mobiles, if you take example, even the mobile we are using, so different companies they are manufacturing different mobiles. So they are segmenting the mobiles based on the charging time also, quick charging, some fast charging. In the advertisements also they are, mentioning this particular mobile is having feature of quick charging. That means if you put a charge about half an hour, we can use that mobile for about 1 day completely like that. And we can go with the combination of a solar and some traditional power supply. So not only solar, wind also we can use, and some management system. So if you dependent on renewable as well as traditional mixture of solar and traditional, so we should take proper care about the grid. So that will be synchronized correctly. Why? Because whichever the output you are getting from the grid to the charging station, that should be a constant one. It should be a very constant one. So this is very important. This plays a key role. The energy management system, the renewable resources, and the grid are connected with the electrical vehicle charging station. And this we will come to this Beowulf optimization tool. So we go for this one, the GW. This is to find best solution for EV charging station with a multi-level inverter. So we are using 4-level inverter, which is connected to the PV panel, solar panel, and the analysis is carried out with the multi-level inverter solar panel connected with EV charging station successfully in. We have done with Simulink and MATLAB background. So based on the main technique we are optimizing technique we are using GOW technique. So based on that we fix location and the level of EV charging station. So we make it one door. So how we can able to get locate using this some algorithm. So first we will come to know. So location. If you go for the location, several locations for installing here CS means charging stations. Well, suggested in in the earlier studies, categorize. We can go for categorization like the frequent stopping locations where we can frequently we can stop for vehicles. Basically, refilling stations like petrol pumps and diesel pumps, and some parking lots where you will go for shopping and all for over 2 or 3 hours. If you go for a movie, watching a movie in a multiplex, so we need to park our vehicle for about 3 hours. So for the 3 hours, we can, if there is a chance of having a EV charging station there, we can use that one. So next possible stopping location based on their route distance tracking. So for example, if you if you are moving from one city to another city, so we can't get at the familiar distances, we can't find proper charging stations. So in that particular route, we can't able to go with our EV. So this is very important for the where we need to track and whether it is a grid aware network availability is there or not. And next, coming for the levels, there are 3 charging levels were investigated and considered in the infrastructure in terms of their planning, designs, and algorithms. As per level 1, so level 1 is meant for standard operating at 120 volts, 15 to 20 amps. So the kilowatt rating for this is very less, 1.44. And level 2, which is used for commercial. Commercial in the sense we can go for some like cargo vehicles and all, which are operating at 240 volts single phase and 40 to 40 amperes. Here we can see the increment of current rating from 20 to almost 40 double, and also the wattage is has been increased from 4 times. It has been increased from 1.44 to 6 kilowatt. And this is based on the motor we are using in the EV. And the third one, so a very necessity one. So today we won't spare even if we waste some minutes of time. So all we are in a hurry. So definitely we need to develop this type of fast chargers. These are very important. And level 3, which comes under level 3, charging level. So this will operate at high voltage and high current. And coming for the kilowatt rating, it goes around 90 kilowatt. So 90 kilowatt rating motor, if we prefer, means automatically the torque, whichever the output features, mechanical features, that will be more. And coming for the background, some literature survey and all. So we will come to know what about the Grey-Wolf optimizer does and all. So it will go with the objective functions. The network was optimized by selecting the best charging station locations and for the EV charging stations. It provides infrastructure maximum, and we can expect a maximum profit. So majorly, for example, if you have installed a EV charging station at a particular location, so then that particular area, majority of the population, majority of the crowd, if they go with IC engines, so nobody will come to know. Nobody will come for this charging station for their vehicles. Why? Because they are running their vehicles with either diesel or petrol, so combustion engines. So in that times that is not feasible. So for a owner or someone, you won't estimate any. We can't estimate any profit for that selected set of charging stations at each time. And here and normally we came to know about algorithm which works on 4 types of gray wolves are there. Like we can categorize it into alpha wolf, beta wolf, gamma wolf, and all. So alpha, beta, gamma, and the final one is omega. So basically, the wolves will travel in while going for hunting. This will travel in terms of a group, like a pack. If the pack may size between 5 to 12 wolves, like that. So the first one is a leader one, alpha wolf, which decides the prey, and the beta one, which helps the leader and it gives the feedback to the leader. And the third one, it provides a role, it provides food for the pack, for the group. And the fourth one, so it is the lowest cadre one. So if it is not possible to go for hunting of that particular prey, so finally the blamed one is the omega one, which is the lowest cadre, and it is also once after successfully getting the prey, and the last one to it is omega wolf only. So, but this plays a key role. Even though it is having lowest priority, like a scrap goat, it is a victim which will be viable. So, in case of no omega wolf, so all the three will be lossless. And the main steps or the main strategy is they will first search for prey, and they will go for tracking, chasing, and approaching the prey, and they will encirculate and harass the prey until the prey will stop to moving. Why? Because that should be eatable. So if that is moving, the prey cannot be going to eat. And the final one is attacking the prey. So the fittest possible solution for the first time we'll get is from this alpha one, and the second fittest solution we can able to get from beta, and the third one is from delta, and the finally omega, which is the last one that follows all these three poles. And coming for this mathematical method, so the for encirclement of the prey, it will be modeled like this. So where d comes as the distance, and d is equal to c into x into p of t minus x into x of t, where x into p of t means that is a location for the prey, and x of t means it is the position of the grave. And if you go for the iterations, x of t plus 1, number of iterations, coefficients minus a into d, where a and d are the coefficients vectors, and xp is the position vector of the prey, and x is the x of t, I mean x is the position vector of the grave one. The coefficient vectors a and c are obtained from the equations like a equal to 2 into a into r1 minus r minus a, c is equal to 2 into r2, where randomly these we can give the values for r1 and r2, which we can be uniformly distributed between 0 and 1. And a is a linearly decreasing coefficient. It can decrease from 2 to 0. So the first possible three solutions are always saved and used for forming the new solution. The solutions will be like this: x1 is equal to x into alpha minus a1, and so on. Like x into beta minus x2 is equal to x into beta minus a2, and so on. So the new possible solution is found by this the iterative methods. So the best possible solution is x of t plus 1 is equal to x1 plus x2 plus x3 by 3. And how we can relate our grave wolf optimization in terms of locating and the dynamic management for this charging station for EV charging station. Here we need to like some parameters. We need to have some parameters like alpha, beta, gamma, and x of t and x of t and d, where d is the distance factor. So n is equal to number of parking slots including sockets, so which we can be known as maximum allowable number of EVs in the charging station. And the capacity, what about the capacity, maximum capacity EVs being served, plus what about the waiting time which were in the queue, and the number of charging sockets is given by mu, charging rate, service rate per minute. Just now I told you, when you go for a normal petrol pump or normal fuel filling station, they will charge per liter, diesel this much per liter, and like in the same way, charging rate also should be taken as one of the parameter, service rate, and EV arrival rate, when the EV has been rate arrival to the charging station in terms of 1 per minute, and alpha the entering probability when the charging station is full, 0.3 for all experiment. And coming for this one, proposed one. So by using this Simulink MATLAB background and a 4-level multi-charger, so this is the circuit model of solar which we have designed for this charging station for get one, and how to get best position and level of grid and EV charging station. So best position level of multi-level inverter by using this Grey-Wolf algorithm. So grid interconnected PV system. Here we are using PV also, of course PV and normally a traditional power supply, regular power supply from the grid also we can use. And this is the characteristics we got EV charging station based on the location, which we can able to trace with the different parameters. And this is the normal algorithm where it is a casual, I mean normal general gray wolf optimization algorithm which you can use with some fitness parameters and all. First, we need to say initialize some parameters A, small a, capital A, and C, and assign some values like searching agents, fast searching alpha, some second level, second fish one, alpha, beta, and gamma values. And this is how we can get and we can update the values of coefficients x of x alpha, x of x beta, and x of x gamma, and we can get the solutions. Right. Once if we are not getting able to get proper solution, that will later the iterations will be going for counting 1 plus 1. Right. So this is a normal specifications of different AV segments. So when you go for cards, which is in the fourth one, so the capacity is around 30 to 80. So with this capacity, so they need to have a third level of charging, quick charging. So like voltage also has been increased up to 500 volts. If you normally go for a two-wheeler, a normal two-wheeler, it is having very less battery capacity, around 1.2 to 3 or 3.5, and voltage also is very less. So this is about uh, my presentation. Thank you all.
Very good presentation.
Sir, thank you, sir.
And is it audible?
Sir, your voice is audible to me, sir. Go ahead, sir.
You have given an excellent algorithm method,
Sir, sir.
gray wolf optimization.
Yes.
So, which is the fittest solution in mathematical model for gray wolf GW?
Yeah, yes, sir.
Fittest solution in mathematical model, gray wolf optimization.
So we can get with agent alpha, sir. Searching agent alpha.
That is the second one.
Sir.
Audible?
Sir, audible, sir, audible, sir. So we can go with the.
Consider the first one is alpha.
Yes,
the
sir.
second and third best solutions. What is it?
Second and third, sir. For example, it's a quite logic question. If the first one alpha is not able to catch the prey, immediately in that group, second one should be. I mean, just like sir, our coordination. We know about coordinations of protective systems. Fuse to circuit breaker coordination, circuit breaker to circuit breaker coordination, relay to circuit breaker, like that, sir. One is a protecting device, another one is a protected, like this. So while going for hunting. So so normally they will be in an organized manner. They will hunt in an organized manner. In such a way, we'll first select the parameters. Sir. So selecting the parameters here is very risky task, sir, for this location.
Okay. So which is the subordinate walls help the alpha in decision making?
Sir, alpha is just like a king, sir. It is in the decision making and where to sleep, which type of prey need to catch and all. The decision is taken by the head like alpha, sir. Alpha.
Which is a subordinate?
Which is a subordinate means last one, sir. Fourth one. Fourth comes
Beta.
like
Beta.
alpha, beta, gamma, omega, sir. It is omega. Last one.
So what is mean by omega wall?
Omega wolf means this is just like a last one, sir. So just like if any king will order, no, sir. For example, we need to go for a war. So directly king will not involve, sir. Finally, ultimately the lowest one, like what we can say, the Sipai, we can say, like he will be in the front line, sir. He will be in the front line to face that issue, sir.
So how do wolves choose the alpha?
Sir, how the wolves?
Choose the alpha.
How the wolves choose the alpha? Yeah. Sorry, sir. I didn't. No. I didn't know about this point.
See, alpha implies competing with others, right?
Yes, sir. Yes,
and
sir.
becoming the top by winning a contest or a battle.
Yes, sir. Yes. Yes.
So, okay. Any other question from audience?
So, any more questions from the participants? Any more questions? Okay. Considering no questions, thank you so much, sir.
Thank you. Thank you also. Thank you.
So
Right.
please close your presentation.
Right.
So moving forward to the next presentation, may I call upon Mr. Veernaran Reddy and team. Sir, are you online?
Yes, sir, Aslam sir. I am here.
Okay, sir. Uh, so Praveen sir, please stop sharing, sir.
Yes.
So please start sharing your screen, Veernaran Reddy.
Yes, sir. Sir, is it visible, sir, Aslam sir?
No, no. Please
No.
start sharing the screen first.
Sir, already shared that.
No, sir. At the bottom, there you see an arrow mark pointing upwards.
Ah,
You just click on that.
share it then.
As soon as you click on that, you will get a small pop-up window where you see three options. Your entire screen
Sir,
will.
already I shared entire screen, sir.
So we could not see your screen, sir.
Sir, wait, sir. 1 minute, sir. What happened?
Sir, shall I go with the next presentation, sir?
Yes, please, sir. Proceed.
Okay, sir. Uh, Mr. Vinarana, please wait for one presentation. Soon after we conclude the presentation, you start your presentation. Till now, just rectify the technical issue you have. Okay. Miss Nisi and team, are you online? Nisi Api, are you online? Penchalaya and team, are you online?
Yes, sir.
Penchalaya and team, are you online?
Yes, sir.
Okay. Start sharing your screen, Nana.
Okay, sir.
See, at the bottom, you have some icons.
Okay, sir.
There is a arrow icon pointing upwards. Just click on that.
Yes, sir. Is it my screen is visible, sir?
Yes, it is very clear now. Now you may start your presentation.
Okay, sir. Good afternoon, all. I am Penchalaya and my co-authors are Kiran Kumar and Sai Charan. Today we would like to talk about an electric car. First, we are going to introduce first. We all know that an electric car is run by consuming electricity. Okay, consume electricity is called an electric. It is more durable and mechanically strong than a gasoline. And 1 minute. Hello.
Go ahead, Nana.
Okay. Sir, you-
Any issues from your side?
Sir, 1 minute, sir.
What's wrong, Penchalaya?
Hello, sir. Sir, is my voice audible?
Your voice is audible. Your voice is audible. Please share your screen and start presenting. Mr. Veer Narana, are you ready with your presentation? Miss Nissi? Miss Nissi, are you ready with your presentation? Vamshi Kalyan, are you online?
Yes, sir. I'm here, sir.
Vamshi Kalyan, please mute other devices if you have.
Sir, am I audible, sir?
Yes, you are audible now. Please share the screen. Okay. Put the screen on full screen board, Nana. There is an icon at the bottom, at the side of the comments. There are 4 icons. Press on to the slideshow view. Okay. You are not audible. Vamshi Kalyan, you are not audible. Unmute yourself. No. Unmute yourself first. You are not audible. Sorry for the inconvenience, Stalin sir. The students are facing some issues
No problem.
while presenting there. Yes. Thank you so much for your patience, sir.
Good afternoon, sir. Am I audible, sir?
Yes, it is audible now. You just unmuting yourself. Just start sharing your presentation. You muted yourself again. Please unmute yourself, Nana.
Sir, good afternoon, sir.
Yeah, good afternoon. Now please start presenting.
Yeah, sir. First, I am thankful to you, sir, for giving this an opportunity. My name is Hemant Reddy, and my team members are Vamshi Kalyan and Sudarshan. Our topic is modeling of electric vehicle charging station for DC fast charging. Coming to introduction, in past few years, the usage of petrol and diesel is increased. So by this, the emission of carbon gases increased. So that air pollution occurs. To reduce this, we introducing electric vehicle with a DC fast charging, sir. The main agenda of this idea is to reduce the charging hours and increases the mileage hours of electric vehicle. Electric vehicle is also used as an alternative to reduce the usage of fossil fuels. Is an EV right for me. Electrical vehicle, how electrical vehicle is used, and is it affordable to usage in daily life? Electric vehicles are affordable. Electrical now present electrical vehicles usage is somewhat less. So the usage of electrical vehicles are less. The price is somewhat um, high, sir. When in future, when we go to future, everyone can use electrical vehicles. At that time, the electrical vehicles are cheap. Can get cheaply, sir. How and where would I charge an EV? We can charge in we can charge electrical vehicles in three types, sir. Level 1, level 2, and level 3. When come to level 1, we can use AC as a electric medium, sir. By this we can charge the electric vehicle by using 3 pin. And for increase the charging hours to in a minimum time and increase mileage hours, we can use DC fast chargers. Should I buy new or use it, or is it better to lease? As per our usage, the price can made by the cost and the paid by the user. We can buy it new, or we can also take as is. Will an EV go enough miles between fill-ups? Yes, sir. By going with the proper charging, by using DC fast charger, we can uh, charge up the electric vehicle in a fast manner, and the mileage also good in hilly areas and up and downs also, sir. What type of EV is the best for me? Electrical vehicle which is has combined charge types, sir, which has both AC and DC. Both AC and DC type, which can which can charge quickly and give some mileage, sir. Is charging and cheaper than buying gas. Yes, sir. When we move forward to future generation, everyone can use. At the time, the charging stations also increased. At the time, the buying charging an electrical vehicle is cheaper when compared to buying gas, sir. When coming to review of charging stations, there are three types of charging stations, sir. We can charge the electric vehicles in three ways: level 1 and level 2, level 3. When coming to level 1 charging station, in level 1 charging station, we can use a we charge the electric vehicle in a homemade, sir, by using a three pin. By this, it takes more time when compared to other levels. In level 1 stage, we can charge up to 8 hours. It takes 8 to 10 hours. By that, the increase of charging time is increased, and also miles also compared to coming levels. This level 1 charging station has low mileage, sir. For that, we go with level 2 charging station, sir. In level 2 charging, we can use it is somewhat better to level 1 charge, sir. In level 2 charge, the charging charging requirement and the mileage also decrease. Mileage improves and the charging hours also decrease, sir. We can charge the we can charge in level 2 easily, sir. It takes 4 to 6 hours, sir. And we can use it in public places also, sir. When we go with level 3 charging station, in this we updated compared to level 1 and level 2, we can use it by using DC fast charging. The charging time is lesser and mileage also it gives very good. It takes more minimum 30 minutes or less than. So by this, the whenever we use it in public places or else any homemade, the traffic when we use the DC fast charging in public places, it takes less time. By this we can by this the traffic rules or any we have any immediate, we can go to some places immediately. At the time we can reach very safely and quickly, sir. So by this DC fast charging, this DC fast charging, two types of pins there, sir, AC and DC type, and 3-pin and 2-pin. By this we can use whatever we do want. Now we can use it in public places or else in home. Mainly we can use in DC fast charging type combined charge system, sir. By this the charging hours are reduced and the mileage also comes very good, sir. And this is the type we can charge the car, electrical vehicle in this manner, sir. EV battery charge schematic model. EV battery, the electric vehicle inside battery has it as it is in the model, sir. We can get a power grid we can get electric power by power grid. By this AC, we can AC to AC power we convert to DC, and DC the pulsating DC which has we get in a AC to DC converter. By using DC to DC converter, we can completely convert this into DC. By this, we can charge the electric vehicle very in a quick manner, and we get a proper mileage also, sir. Battery charger model in a schematic in inner part of the car or electrical vehicle. By using a MATLAB or Simulink, we can get an scope which is output. How can we get this charging anything by using converter batteries, controller? We can convert AC to DC and complete it DC to. We can get this. This is and this is the circuit. We have to battery can store the power, and which gives to electrical vehicle or something like a car or motorbikes. The storage is by using a capacitor. Capacitor can store to reduce unwanted anything unnecessary currents. We can use the resistor. By this we can get as output as an electrical current, sir. And by this we can conclude as this presentation. We can use it is as an alternative method to save or to protect the fossil fuels, petrol, diesel. It is an alternative medium. We can use it as an alternative medium. And the main agenda or the main aim of the idea is we can reduce the carbon gases by introducing these electrical vehicles. So to reduce the minimum time, we can use the DC fast chargers. By this we can charging hours are also charging hour time is reduced and mileage also increase, sir. That's all about it, sir. Thank you, sir.
Okay. Am I audible?
Sir?
My voice is clear?
Hello, sir.
Okay. Now audible?
Sir, 1 minute, sir.
My voice is audible or not?
Hello, sir.
Is examiner's voice is audible or not?
Yes, sir. It is audible, sir.
See, the topic is modeling of electrical vehicle charging station for DC fast charging. Okay,
Sir.
right? What type of modeling you have done it in this presentation? What is the tool used to make your modeling?
Sir, your voice is not audible. Hello, sir.
See, modeling of electrical vehicle charging station for DC fast charging. That is your topic, right? Audible or not?
Vamshi Kalyan, just put on the captions option at the bottom, Nana, so that you can see the text at the bottom. So there are some options. Just turn on the caption icon.
My voice is audible, right?
Hello, sir.
Can you hear examiner's voice?
Yes. Now it is
Yeah.
audible, sir.
See, your topic is entirely different and your presentation also different. So what is the modeling you have done it for this electrical vehicle charging station? What is the tool used to make your modeling? You are given
Yes, sir.
3 different level of charging.
Yes, sir. To reduce charging hours and increase mileage, we can use this upgradation, sir. Level 1, level 2, and level 3. By using level 3, we can use a DC fast charger, sir. By this, we can reduce the charging time and increases the mileage.
No. What is the modeling you have done it for making an electrical vehicle charging station?
DC type, sir. In this, we can use combined charge system, sir. By this, the mileage can increase and charging hours also reduces.
Okay. I think you have not understood my question.
Okay. So, any questions from the participants? Okay. Thank you, Vamshi Kalyan. Just stop sharing your screen.
Okay, sir. Thank you, sir. Thank you so much.
Mr. Veeranarayan, are you ready? Mr. Veeranarayan.
Sir, NISI team will continue. Aslam, sir.
Yes?
NISI team will continue the presentation.
Okay. You see. Start sharing your screen.
Okay, sir. Is visible, sir?
Yes.
Go ahead.
Good afternoon, sir. This is Nisi Afia Kinnera from 2nd Triple E and my co-teammate Reddipalli Swati. Today we are going to explain about a review of network modeling and future research needs. This is the introduction about my topic. Basic electric vehicles are believed to be an effective solution for reducing greenhouse gas emissions. Despite extensive study on the attributes and characteristics of electric vehicles and the charging infrastructure design, the development and network modeling of electric vehicles are still evolving and limited. Carbon-based emissions and greenhouse gases are critical issues that policymakers have sought to address globally since the Kyoto Protocol issued in 1998. Firstly, the transportation is 98% dependent on fossil oil, which is exceedingly affected by changes in energy resources. Secondly, governments and automotive companies have recognized the value of alternative fuel vehicles for green transportation and have been implementing economic policies to support electric vehicles market. However, a more widespread use of EVs is still hindered by the limited battery capacity, which allows cruising ranges between 150 and 200 kilometers. In addition to the AVs or built remains the most intractable barrier. This is the battery model of electric vehicle, where Thevenin's equivalent circuit model, where battery model of electric vehicle is consists of Thevenin's equivalent circuit model along with improved Thevenin equivalent circuit, and it have PNGV model, where PNGV is known as Partnership for a New Generation of Vehicles model of the discharge process is established in this paper. Based on the PNGV model, the internal resistance correction method and the Kalman filter method are used separately to evaluate the battery. PNGV is a representative model of the nonlinear low-order Model 1, which was formally proposed in 2001 and then became a classic model to study the equivalent circuit model in power batteries. Next. This is the charger model of electric vehicle, where it contains the charging missions, one of the main equipment of the electric vehicle charging station. Charging machine is a kind of power electronic equipment which is composed of rectifier, DC-DC converter. The working principle of charging machine is as follows. Firstly, the inputting three-phase alternating current is rectified by rectifying circuit. Then through filter circuits, it provides direct current for high-frequency DC-DC power transfer circuits. Where a rectifier is a device that converts an oscillating two-directional alternating current AC into a single-directional direct current. Next, power transmission is the movement of energy from its place of generation to a location where it is applied to perform useful work. And then every car has four main filters: the cabin filter, oil filter, fuel filter, and air filter. The function of all these filters is to be enable flows and catch impurities, like the dust and the contaminants in the air, the impurities in the fuel, or the dirt in the motor oil. Next. This is the charger model of PWM commutator. The PWM rectified charging machine's main circuit use three-phase voltage source PWM commutator consisting of IGBT and diode. By using PWM rectification charger, we can control current on the grid side by controlling voltage of PWM rectifier on the alternating circuit, where PWM is used in many applications ranging from communications to power control and conversions. For example, the PWM is commonly used to control the speed of electric motors and the brightness of lights, and in ultrasonic cleaning applications and many more. Next, this is the model view of a EV car, where it consists of power electronic, electric motor, radiator, engine, and etc. Where radiator is known as, like, some electric cars do have radiators to cool down the batteries as well as the converters and the motor, but not at all electric cars have radiators. Instead, some electric cars use other methods to keep internal components, like air cooling works basically like a fan. Older electric car models tend to use this model. Liquid cooling cools the electric car's components through a series of pipes. Sometimes radiators are actually used to do this in electric cars. Heat pumps are commonly used by Tesla. They basically transform heat from where it is not needed to a different area. And some top electric cars in the India market, like MG and Tata Tiger, Hyundai Kona, Mahindra, etc. And that's it up to my part. And now my teammate Reddipalli Swati will continue. Thank you, sir.
Good afternoon, sir. Myself Swati from 2nd Tripoli CVIT. Today I am going to explain type of batteries are being used in electric vehicles. Electric vehicles are powered by battery electric power. Different type of batteries are available in the market. They are lithium-ion batteries, solid-state batteries, nickel metal hydride batteries, lead acid batteries, and ultra capacitors. However, lithium-ion batteries are the most efficient and preferred. Lithium-ion batteries are currently used in most electric vehicles because of their high energy per unit mass relative to other electrical energy storage systems. They also have a high power to weight ratio, high energy efficiency, good high temperature performance, and low self-discharge. Most components of lithium-ion batteries can be recycled. Most of today's electric vehicles use lithium-ion batteries, though the exact chemistry often varies from that of consumer electronic batteries. The other is a solid-state battery. The all-solid-state battery consists of a cathode composite layer, a sulfide solid electrolyte layer, and a carbon-free microsilicon anode. Before charging, discrete microscale silicon particles make up the energy-dense anode. They differ from lithium-ion batteries. The next is nickel metal hydride batteries. Nickel metal hydride batteries have a much longer life cycle than lead acid batteries and are safe and abuse tolerant. These batteries have been widely used in hybrid vehicles. The main challenges with nickel metal hydride batteries are their high cost and self-discharge and heat generation at high temperatures and the need to control hydrogen loss. The next is lead acid batteries. Lead acid batteries can be designed to be high power and are inexpensive, safe and reliable. Low specific energy, poor cool temperature performance, and short calendar and cycle life impair their use. The other is ultracapacitors. Ultracapacitor stores energy in a polarized liquid between an electrode and an electrolyte. Energy storage capacity increases as the liquid surface area increases. Ultracapacitors can provide vehicles additional power during acceleration and hill climbing and help recover braking energy. Uh, they may also be useful as secondary energy storage devices in electric drive vehicles because they help electrochemical batteries level load power. This page indicates the conclusion of electric vehicles. At the present, vehicle to grid concept is on the rise. V2G reflects the relation between electric vehicles and the power grid. The V2G bidirectional charging and discharging device based on PWM can realize the energy interaction between power grid and the electric vehicle. The PWM commutator model is essential for V2G simulation. In case of battery model, PNGV model has more advantages. So the PNGV model was recommended as the battery model of electric vehicles.
Thank you, sir. This is all about a review of network modeling and future research. Any queries, sir?
Okay, you are given a different model and what are the different type of batteries used in the EV electrical vehicle, right?
Lithium-ion batteries, ultracapacitors.
Now, which type of battery is used at present?
Lithium-ion batteries.
Why?
They are high mass.
What is the size of the battery? Or in
Size.
terms of capacity control? Each battery, what is the capacity?
Sir, the size of lithium-ion battery is 21.5 into 70.5 mm, sir.
17?
70.5 mm, sir.
No, I'm asking the capacity. 17.6 kilowatt hour. 17.6 kilowatt hour. Okay, this will be moving up to 58 miles. Up to 100 kilowatt hour in the Tesla model is also they were introduced. Okay.
Okay, sir.
So what is the voltages in an electric car battery?
Sir? Sorry, sir?
The voltages of your battery.
Sir, repeat it again, sir. I can't hear you.
When I ask question, all people say I can't hear. I can't.
It's not audible here, sir.
Okay. So what is the efficiency of your battery?
Efficiency.
Efficiency of
Efficiency.
Sir, it's 90%, sir, above 90%. Where nickel-based batteries are 80%.
Okay. Do you know the battery structure? Are you familiar with the battery structure?
Yes, sir.
You tell me, what is the function of electrolyte?
Uh,
Tell me any one electrolyte. Name any one electrolyte. Like acid battery or whatever the type of battery.
so there are 7 different components makes it battery, sir.
Hmm.
Like electrodes, electrolyte, and collector.
What is the electrolyte used in the battery?
electrolyte separates the anode and cathode.
What is the function of electrolyte?
It transfer chemical energy into electrical energies.
Is it a variant or invariant? Hmm? Okay. In which type of battery used in general? Nowadays in all cars they use different type of batteries, right?
Lithium ion batteries.
That is for your electric car. Any other batteries? Okay. Okay, thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, Nisi. Okay. Please stop sharing your screen. Mr. Veernarana, are you online, sir?
Hello, Aslan sir.
Sir, are you online? Ready to present?
Yes, sir. Yes, sir.
Sir,
From
please.
Gausha Madam account, I will share my screen, sir.
Okay. Please start
Ah,
sharing your screen.
yes, sir.
Any issues, sir? Okay. Sir, please unmute yourself. Mr. Veernarana, please unmute yourself.
Yes, sir. I am.
Okay. Now put the presentation on full screen.
అది unmute చేసినావా? Hello.
Sir, put your presentation on full screen. Okay. Now you may start your presentation.
Sir, my topic is electric vehicle battery infrastructure. Is it audible, sir, now?
Yes, sir. It is very clear. Continue.
Ah, okay, sir. Sir, my topic is electric vehicle battery infrastructure. I am going to, sir, I will go ahead, sir.
Please carry on, sir.
Ah, yes, sir. Sir, my project content is description of my work and electric vehicle classifications. Energy storage system means batteries, electrical supply equipment, classification of EV chargers, EV charger impact on utility grid, international standards on electrical vehicles, future adventures, and finally conclusions. Description of my work, sir. Nowadays, electrical vehicles are more prevalent in the transportation sector. To promote the electric vehicle, whatever advantages are in the electrical vehicle, you should overcome our disadvantages with advantages. What are the impediments due to in the electrical vehicles are high cost and charging limitations. We need to we have effect of electrical vehicles on the our power grid. What are those effects we will discuss at the topic, sir. Next, it is the working of our electrical vehicles. Whatever electrical vehicle heading battery, first is the battery storage. From battery storage, our power converters are give the whatever the electrical power required for the motor from the battery. For example, battery is 100%, that is given to power converter 99% almost. From power electronic converters, loss of 5% from converters, and it given to motor 95%. Motor will convert this electrical energy into mechanical energy, that is rotation of our wheels, and the wheel is transmission the our load or vehicle is moved. This energy conversion is from motor to wheel 92%. Here 8% is the mechanical losses. From battery to electrical conversion, 1% of electrical loss. First loss from battery to power electronic device, 1% of power loss, and from power electronic device to motor, 5% of electrical losses, and motor converts the mechanical energy, 20% of mechanical losses. Major losses this conversion is power electronic losses only. This is the electrical vehicle. When come to internal combustion engine, here petrol diesel tank, from petrol diesel tank, petrol will or diesel goes to diesel petrol engine, and engine will rotate through gear and transmission. You need to control the speed of our vehicle. And hybrid vehicles. So here we discuss the electrical vehicles and internal combustion engine and hybrid vehicles. Three are different. Only electrical vehicle means only battery, power electronics, converters, motors, and energy. Here role of the power electronic converters in the electrical vary is more. Since if it is battery rating is different, motor rating is different, means these two ratings are adjusted by power electronic converters. Here in the electrical vehicles, power electronic converters plays the major role. In the internal combustion mission, petrol diesel engine is decided by our gearbox, means our speed decided by gearbox position. This is the difference. Combination of this electric vehicle and internal combustion gives the hybrid vehicle. Here we taken as a hydrogen gas and liquid hydrogen for the internal combustion of hybrid electric vehicle. So combination of these two gives hybridization. Fuel cell gives the electrical energy only. Here power electronic devices is common for hybrid vehicle and electrical vehicle. This is the different vehicles and their efficiencies. Next to EV electrical vehicles classifications. Electrical vehicles I have discussed here. Battery electric vehicles means our general electrical vehicles only. No hybridization. This is only battery electric vehicles. If you lose battery means, if you lose the battery charging means, we need to stop there only. Again, you need to charge battery. Next, plug-in hybrid electric vehicle means it has both fuel and electrical motor. With plug-in means you can charge. Only hybridization means you have battery and fuel vehicle, but not plug-in means at the time of you are losing the electrical energy means you need to go with fuel only. Here, if fuel also not there means you can charge by plug-in directly. Like AC traction, wire plug wire is along with the track. That is the plug-in hybrid electric vehicle is traction in the traction. Hybrid vehicle means in the general we are using the electrical vehicle plus diesel petrol vehicle. That is the hybridization. Plug-in hybridization means you have electrical vehicle plus combustion plus along with the plug-in along the track. This is the difference of these three vehicles. Next, energy storage systems means batteries only. Energy storage system means batteries. Generally, we are failed at the battery storage only. But lithium-ion batteries are more efficient batteries. Nowadays, we are using lithium-ion batteries only. Nickel, cadmium, nickel metal hybrid batteries are olden days batteries. Now, lithium-ion batteries are modern batteries. Next, electrical vehicle equipments. Generally, at the electrical vehicles, we have electrical components, batteries, first battery, charging, plug-in. So while charging, you need to indicate some LED information. That required LEDs display of how much you are charged from 0 to 20% or 30%. That is displayed on everything on display. LED gives the indication whether charging mode or off mode. Next, plug and charging mode is there. This is general natural method in what we are using, but automation procedure you need to go for LEDs and display methods. Next, charging of electric motors in two ways: DC charging and AC charging methods. DC charging means no need of any electrical converter like rectifier. You can directly store the electrical charge directly. Half-board charger means no need of any power electronic device. You can charge directly. That is DC charging or half-board charging. It is fastest method when compared to AC charging. Means since in the AC charging mode you need to go onboarding means power electronic devices and convert into DC and again store the electrical energy in lithium ion battery. That is the concept. There are two types of charging of any electrical vehicle. One is DC charging or AC charging. DC charging also known as off-board charger or off-board charging, because there no need of electrical conversion. Directly you can store the DC energy directly. So you may call it as off-board charger. In AC charging, you need to convert AC energy into DC, because we are not store the AC energy directly. That's why you need to go for rectifier, that is called onboard charger, and it is stored into electrical energy. Generally, electrical energy again can charge in two ways, wireless and wired. That is decided in, that will come on next slides. Yes, electrical chargers classifications. Single phase, three phase chargers which may unidirectional and bidirectional port capacity. That means you can supply the energy to battery and battery to electrical vehicle. That means bidirectional. Again, unidirectional also you can charge or discharge. Both you have, so that both can occur at a time. Means charging and discharging both can occur simultaneously. That is may bidirectional or unidirectional. Generally, energy transfer from one place to another place means electrical energy generally in two ways, inductive or conductive. Inductive or conductive. Inductive means no use of wires. It can transfer directly with wave with the help of electromagnetic waves. That is called as inductive charging. Conductive means with help of chargers or conducting wires. When you compare inductive and conductive charging methods, inductive charging method does not require any charger. It can charge wirelessly. Means,
Sorry to interrupt, sir. Vinay sir.
yes, sir.
So maximum time is allowed for one. I mean, author is. I mean, for one paper is 15 minutes, sir. So,
Yes, sir.
Be fast, sir. Be quick.
Okay, okay.
Right. We need
Okay.
to go for valedictory function. Right.
Yes, sir.
Thank you, sir. Go ahead.
Major inductive chargers are very less in magnitude because it requires the electromagnetic wave conversion. That's why they are not used and they are slow in charging. Inductive charging is very fast and they are less cost. That's why we are going for conductive only. That means with wire. Inductive charges are means static inductive, dynamic inductive, quasi-inductive. Dynamically, how they are charged means you need to require next slides. You need to go in next slides. Conductive charging means we are directly giving wires in the for the car. See the car. There we are giving the wire directly. EV charges impact on the utility. What are the some what they are giving some effects to our grid, our electrical grid. Since whatever charging now whatever charging you are taken from our grid only, due to this electrical devices you have the power electronic device like rectifier, inverter or chopper. Generally in the electrical vehicles we are using chopper or rectifiers since they are dealt with DC only. DC means either rectifier or chopper. In the electrical vehicle charging, we are go for chopper or rectifier. These two devices are power electronic devices. They are giving the some harmonics into our grid, which results the instability in the power grid, imbalance between the supply and demand. Grid voltage will up and down, either power swell or sag, either increase or decrease. That is depending upon device you are used in the electrical vehicles. Next, some international standards are there for the electrical vehicle designing. If you are designing electrical means you need to follow some standards which are given in the next slides. So future advancement in our project is development of onboard charger with minimum equipment additional of power electronic interface circuits. So as you are reducing the power electronic devices in the electrical means you can efficiently utilize our grid. And new and optimized design of our power plants and efficient at wireless power transmission. You need to go for new optimization designing methods such that they can charge speed or power loss less. Like that, if you go, then it is efficient method. So electrical vehicles we are using means you need to go for finally what is my conclusion is whatever negative effects such as harmonic injection and charging time is more. These all are reduced effects by new trendy methods in the power electronic devices. That's all, sir.
So you are given the brief research
Hello, sir.
papers.
Sir, Stalin, sir.
Is it audible? Audible to you?
Yes, sir.
My question is whether you tried any practical model, any contactless charger or any other things with your all
No,
papers?
sir. I am planning to try, sir, but as of now, no practical, sir.
Okay, for a contactless charger, what could be the practical difficulties you faced as per your?
Yes, sir. Sir, in contactless means inductive charger, sir, you need to go for electromagnetic waves and you need to create that electromagnetic waves at receiver and transmitter. There is some difficulty,
What
sir.
are the practical difficulties?
Sir, yes, sir. At the it has two, sir. Wireless means you need one transmitter and one receiver, sir. Like our transformer primary, secondary, you have transmitter and receiver, sir. From transmitter, you can send electromagnetic waves, sir.
What are the losses occurring in the contactless charger?
Sir, losses are sir. We need to work out, sir, on this one. But I know what working principles are, but what are the difficulties in that one means you need to study more, sir. On.
Okay. You are given a brief about different type of charging methodology already available in the systems, especially for internal combustion engine and hybrid and electrical vehicle systems, right? So in
Yes, sir.
this, what would be the overall efficiency? You are given individual efficiency for all conversion. Yeah, exactly.
Yes, sir. Here from battery to power plant device 99 power plant device
I
here
am asking the overall efficiency of electrical hybrid.
overall efficiency means less than 50, sir. That's why we are facing difficulty in the electrical vehicles. Their overall efficiency is less than 50 only.
No, you can calculate properly, but the individual you are given is correct, but you can also give the overall efficiency. Okay.
Sir, this is from here to here 99, sir. Here to here 95 means there is loss of 1% here, 5% here, 6%.
Okay.
Here 20% of in 95% we are losing here, sir. Means we get overall here 75%.
Add all this thing divided by 4 you can put.
Overall we get less than 50 or 50 to 60 range, sir. But for electrical vehicles,
electrical whatever you said is very low. 50 means it's very low, inefficient car.
That's why, sir, electrical vehicle efficiency less, sir.
You can search properly and then you can come for conclusions, right?
Yes,
also,
sir.
no need to have a hybrid because of we are using further storage for hydrogen gas, hydrogen liquid. That is also another burden for loading the vehicle, and that will also reduce the mileage. Okay.
Yes,
So,
sir. Because of this two also, this yes, sir. These are because of this two, mileage will reduce, sir.
Anyway, come up with any practical model that is good for your future research. Okay, thank you.
Okay, sir. Thank you, sir.
Thank you, sir.
Okay, sir. Aslan, sir.
Oh, thank you, sir. Please stop sharing your screen, sir. Penchalaya, are you online?
Yes, yes, sir. Sorry for the
Okay,
inconvenience, sir.
okay. Start sharing your screen.
Okay, sir. Sir, is my screen is visible, sir?
Yes, it is. Go ahead.
Okay, sir. Good afternoon, one and all. I am
One
Penchalaya
thing,
and my
Penchalaya,
co-authors. Sir,
just conclude the things in 10 minutes. Okay? Hello.
okay, sir.
Okay.
How, sir?
Carry on.
Mr. Kiran Kumar and Mr. Sai Charan. Okay. Today we would like to talk about an electric car. We all know that a car which is run by consuming the electricity is called an electric car. It is more it is more durable and mechanically similar than gasoline vehicle because it is run by electricity. It gives more fuel efficiency than gasoline because it does not produce emission like internal combustion engine. The recent report shows that there were more vehicles running on a gasoline product in past few years, but now the report has been changed with increasing the usage of hybrid and electric vehicles. People and next we will talk about the construction and working principle of an electric car. As we see that basically electric vehicle is consisting of motor, battery, and power electronic control. We know that the battery stores the electrical energy and it gives the electrical supply to the motor. The motor converts the mechanical energy into electrical energy. The controller is used to control the supply through the battery and motor. By this way, this electric car will work. The charging port is used to charge the electric vehicle. And next, we will go to the components of electric vehicle. There are mainly three components: motor, motor control, and battery. First, we will look about the motor. We know that the motor is converts electrical energy into mechanical energy. In electrical vehicle, we are used the BLD motors. That means brushless, nothing but alternators. These are more effective in the terms of cost, size, higher in efficiency. That's why we are used these motors. And it has only two basic main parts: rotor and stator. The rotor is rotating part which carry permanent magnet, and the stator is stationary and containing stator winding, as shown in figure. And next, we will talk about the motor control. But brushless motor does not have brush and commutator. The electric vehicle which is used brushless DC motor has to use motor control, which is helps to control various properties of motor. Take if sufficient current and voltage applied to. And next we talked about the battery. We all know that the main function of battery is store electrical energy and it will supply to the motor to mechanical energy. Battery. Out of this, we can use the lithium-ion battery. As so, as so in this table, the lithium-ion batteries has more advantage. That's why we use the lithium-ion battery in electric cars. Let's we talk about the next. My friend continue this session.
Good afternoon, one and all. My name is I'm telling about batteries. The main function of battery is to store electrical energy. Most plug-in hybrid electric vehicles are all types of electric vehicles. Due to this, due to advancing technologies, most of automobile manufacturers uses rechargeable batteries. There are different types of batteries are along with their characteristics are shown in figure. Electric is helpful to us. Less running cost than gasoline powered vehicles. It
Okay.
helps us to save fossil fuels.
So
Sir,
how to measure the power density of the battery? Power density. Power density or NF, battery power density. Energy density.
1800.
Okay, you can, sir. Anybody ask any questions? Okay, go to the conclusion.
It is presence the basic controlling the working of the system fully noise free. And also in future is the progress will be going to improve lifespan of batteries. Okay, sir. Okay, thank you, sir.
Give me any one of the battery name and their power density.
What, sir?
How to calculate the power density or energy density of a battery? Give any one example. Say any one battery name and their power density. What is power density? Okay, thank you.
Then
Thank you, Penchala and team. Thank you. So last presentation of the post-lunch session, Mr. Timothy and team. Are you ready, sir?
Yes, sir. We are ready, sir.
Please start sharing your screen.
Okay. Hello, good evening, everyone. So today we are discussing about the topic
No.
charging infrastructure
Hello.
strategies. Yes, sir. Hello.
Please start sharing your screen first.
Yes, sir. Sorry.
Start sharing your screen, your presentation.
Okay, okay, sir. Okay. Hello.
Yeah, go on now.
Is it visible, sir?
Yes, it is. Go on.
Yeah, okay. So today we are discussing about the topic charging infrastructure strategies for rollout into electrical vehicle segment on large scale in urban areas. So getting into the abstract, in the view of all encompassing introduction to electric vehicles, policymakers need to take a call on how to build charging infrastructure to match up the demand. So the policymakers should take a call that how to build the charging infrastructure in order to meet the demand. So as the petrol price and diesel prices have been increased, the demand of electrical vehicles also get increased. So to match up the demand, they have to design the infrastructure of charging ports, and the authorities need to design for charging operational tactics to be followed. So as it is highly economical, people cannot install these stations by their own. So hence the government authorities need to decide and to they have to make some operational strategies to be followed, and one can raise some questions. So regarding how many stations that should be installed in a city or any place, and where the station should be installed, and which type of station it should be installed. That means there are different types of vehicles. There are different kinds of vehicles. So which type of station should be installed, and how much capacity that should be installed. So the data regarding the rate of charging, the charger performance plays a major role while designing the cluster charging hubs. So designing of cluster charging hubs means the group of charging hubs. And this paper puts an effort to explore the changes which can be brought into the charging infrastructure. So to solve the peak loading means whenever in service centers, that means charging centers, there is a peak loading, and means demand of charging have been increased. So peak loading has also increased. So to reduce this, we have two distinct ideas. So to solve the problem, through this paper, we propose two distinct ideas. So coming to the introduction, the major concern in today's scenario is how to reduce the carbon emission to bring down the global temperature and impact it as an human and other living organism on the earth. So this is the main concept of this introduction of the electrical vehicles is to bring down the global temperature and to reduce the carbon emission. This is the main motto to introduce the electrical vehicles. So the major source of carbon dioxide emission is from transportation sector. So only through the transportation of vehicles, 24 to 25% of world's carbon dioxide emission is due to only the vehicle transportation sector. So as we observe in our today's scenario, every home contains 2 to 3 automobile facilities. So in order, the carbon dioxide also get increased. So the shift from traditional, that means the conversion of the idea of conversion of fuel vehicles to electrical vehicles is leads to reduce the pollution and to increase the health of human, and as it contains the lesser noise, it also helps in air pollution, and it also helps in noise pollution also, and increasing in economics for country like India. So as we observe in this graph, so let us consider the graph.
Sorry to interrupt you, Pirula.
Yes, sir.
Please come to the proposed work.
Sir, sorry, sir.
Please come to the main topic.
Okay, sir. Sorry.
Skip this introduction.
Okay. So this is a concept of charging infrastructure strategies, and as we observe the PV plant, that means the photovoltaic plant where the solar energy can be observed, and these, as we can see, these are the channels where the power is distributed. As this charging infrastructure can be designed like this, so that we can use this as a battery storage, and another channel can be used for electrical vehicle charging station, and another channel can be used for building purposes, and for shopping malls, and for other public grids. So optimization of battery pack of charging ports. So there are different kinds of charging stations are there. So slow charging stations has typically 3 kilowatts rating, and charging time is up to 8 to 10 hour duration. So to fill the battery, it takes the slow charging station takes about 8 to 10 hours of duration. Whereas coming to the fast charging stations of 20 kilowatts rating, and charging time is up to 3 to 4 hours. So the duration of charging time is 3 to 4 hours, and another type of charging station is rapid charging station. So this is typically about 43 kilowatts rating, and charging time is only half an hour to 1 hour time. So it takes only half an hour to 1 hour time to fill the battery. So now,
and the conversion of parking slots into charging points. The major concern need to be addressed is a lack of available site space in urban areas for development of required charging stations for large unit rollouts of electrical vehicles. These problems can be greatly addressed by converting the parking slots into electrical charging centers. In urban areas, generally the land is very expensive, and to establish these charging points, it required a large amount of place, and it is a time consuming as well. So why not we convert these ideal parking slots into charging points? So our idea and thought is about that. So the vehicles in the parking slots will be ideal. So we are thinking to utilize this ideal time into useful times to convert these points as charging points out here. So it is a small view of how the charging slots looks like. So we can park the vehicle out there, and we have a number of charging spots out there. So we can easily charge in the meanwhile time. And the optimization of charging infrastructure development. So this topic is mainly discussed about what is the size, the location, the number of charging units, and the distance between each sentence. So to utilize this in a proper way, the localized charging station, which is with a higher number of chargers, they can serve a lot more amount of electrical vehicles at a time. But it will require large space and higher cost, along with the grid integration problems. So the electrical vehicles are of three kinds, namely hybrid electrical vehicles, plug-in electrical vehicles, and fuel cell electrical vehicles. Charging infrastructure developed should meet the charging types of all, because these three everyone can't buy a similar kind of electrical vehicle. So there are number of people, so there are different kinds. So we should we should establish a plant where we can charge all kind of electrical vehicles. So this concept deals with that. And now the grid integration system at the charging units to maintain energy balance. Increasing usage of electrical vehicles will effectively bring down the atmospheric pollution, especially. The carbon levels in the atmosphere will be addressed, bringing down the greenhouse effect. But it may lead to emission or pollution from the power producing units like coal, and also heavy dependency on conventional electricity will put pressure on grid system. Hence, we need to move towards integration system of clubbing the solar-based electricity and the conventional electricity from a grid system to balance the carbon emissions and meet the load demands. Now, while we are coming to the conclusion, the updated battery pack of electrical vehicle leads to faster charging of the battery with minimum time, and the lack of available site space in urban areas for development of required charging stations for large unit rolls out of electrical vehicles can be greatly addressed by converting parking slots into electrical charging centers. The charging stations need to be developed to empower all needs like charging EV vehicles, like hybrid vehicles, plug-in electrical vehicles, fuel cell and electrical vehicles. And to control all this system and manage all this system, we require an operation management, skilled workers to manage and support the grid operation to minimize losses of power, waiting and time optimization, smooth charging operations. To avoid overloading or ineffective usage of available charging stations, Google-based indicator or an app indicating loads at different charging stations need to be developed, like the app which shows where is the nearest spot, what kind of availability and slots available out there, how much time it takes to a charge, and the capacity of the plant as well. And this will lead to avoid of queuing and the service station during the peak load times. And the idea behind this is, as the demand of the petrol, diesel, etc. at the refueling station decreases with increase in the number of electrical vehicles and their charging demands, it would be more profitable to convert these existing refueling stations into electrical vehicles charging stations. Adoptions of new technologies like V2G, vehicle to grid, and smart charging techniques, etc. And here are some of the references that we have collected. And thank you, sir.
Okay. You are given like a research paper. Actually, I need to know, if you have 1 unit of electricity or 1 kilowatt hour electricity available in your battery, then how long time we can travel? How long distance we can travel through electrical vehicle? If you have 1 unit of electricity.
Yeah, sir. It's nearly up to 60 to 70 kilometers per single charge, sir.
No, how long distance you can able to travel?
It can cover the distance of 60 kilometers for a single charge, sir.
In into 1 unit electricity can travel 60 kilometers, right?
No, sir. Not in 1 unit. I mean about in one single charge, sir.
Okay, what are the different charger you refer for this supercharging unit?
Sorry, sir. Can you repeat your question
What
again,
are
sir?
the different charger? Name any three charger. Different
Chargers, sir.
fast charging.
Fast charging.
Fast charging.
Um, like we have discussed in yeah, sir, we have discussed in the slide as well that 43 kilowatts per 30 to 60 minutes. It's a fastest.
Can you use the Tesla car for any other adapter in a Tesla car? Can you use?
Uh, Sir, actually, the Tesla cars filling stations are having a long distance, but our main motive is to utilize the parking space for the charging stations for the vehicles. So, might be these systems can also use in Tesla as well in upcoming days, because the utilization is increasing and the people are purchasing in the purchase. It's increasing day by day, so this will be the further future requirement as well, sir. I think in future this will be implemented in that system as well.
So in future, what would be your research development for making a faster charging as well as long distance coverage? Which type of adapter you can prefer? Which type of charger you can prefer?
Sorry, sir, I'm not aware of that. We are doing we are.
Are you a student or a faculty? Are you a student or a faculty?
A student, sir. He's
I'm
a
a
student.
student.
Okay, you can try for a minimum pilot model charger for a particular distance, 3 to 4 kilometers. Then you can try for supercharger with a pilot model. The thing is, you can optimize the cost. If you wanted to put one public charging station, this will comes around 40 to 50 lakhs, the entire unit. Okay, so you
Yes, sir.
have to concentrate to reduce the cost. Okay, thank you.
Okay, thank you so much, sir. Thank you for your time.
Thank you, Timothy and team. Now the time has come actually. We have completed our all presentations, almost 28 presentations. I would like to inform you have patients. Sir, I request Dr. N. Stalin sir and Dr. K. Katrivan sir to please uh, be have patient with 2 minutes, sir. We are going to start our validatory function. Okay, sir.
Hello. Hello. So very good evening to all. And myself, I Praveen Kumar Reddy, working as assistant professor in the Department of EEE, and welcome you all for this valedictory function of a two-day national workshop, national conference on electrical vehicle charging infrastructure, sponsored by ACTE. So let's have a college intro video, AV. So I request the technical team to run the video.
Chaitanya Bharati Institute of Technology was established in the year of 2008 by Sri Jayachandra Reddy Garu, Chairman of CBIT Group of Institutions with AICTE approval and affiliated to. The college was started as an affiliated college of University JNTUA with undergraduate programs in BTech, EEE, ECE, CSE and Civil, and was given permanent affiliation. In 2016, the departments EEE, ECE were accredited by NBA. In 2019, the departments CSE, Civil were accredited by NBA. CBIT promotes the students to establish contact with the neighborhood communities and interact with them to explore the opportunities for social work. CBIT has earned the reputation of being an industry-allied institute complemented with foreign industry collaboration from Walkite University, Ethiopia, Tata Consultancy Services, India, and Andhra Pradesh State Skill Development Corporation, Vijayawada. A new education era in Rayalaseema region has been started when CBIT, founded by Bharati Education Society, established in the year 2008. Eminent educationalists from Hyderabad, having a reputed academic track record of 20 years, formed the governing body of the college. CBIT branding itself in the society with eco-friendly campus located very near to the city. Proficiency in management, decentralized administration, enviable position among engineering colleges, novel experience curve, and competency of faculty equitable ratio in cadre, gender, and expertise infrastructure over and beyond the basic requirements with the willingness to take challenging assignments.
Thank you. Thank you all. So now I request the co-convener, Mr. N. Varaprasad Garu, to come on to the dais. Sir, please. Thank you, sir. Now I request the coordinator, convener, Dr. R. Sarunan Garu, to come on to the dais. Sir, please. And finally, I would like to request our beloved HOD, Dr. R. Suryaprabha Madam Garu, to come on to the dais. Madam, please. So thank you, madam. And the today's valedictory function chief guest are Dr. N. Stalin Garu, Dr. K. Kadiravan Garu, who are virtually connected with us. Sir, welcome you, sir, to both of you. Good evening, sir.
Good evening.
Thank you, sir. Thank you. And coming for this 2 days national level conference, ACT sponsored on the topic electrical vehicle charging infrastructure. Totally, we got around 100 authors has published 28 research papers. This we are having a very fabulous journey from these 2 days, and we got papers from the authors from the states of Tamil Nadu, Telangana, Karnataka, and Andhra Pradesh, and many districts of Andhra Pradesh. And I would like to request our co-convener, Mr. N. Varaprasad Garu, to come out to the dais and speak about this 2 days event. Sir, please.
Thank you, Praveen sir. Good evening to all. Honorable Chairman sir, Dr. V. Jayachandra Reddy sir, and Director V. Lohit Reddy sir, and Principal of the college CBIT, Dr. Srinivasal Reddy, and Convener of R, Dr. R. Saravanan sir, and Head of the Department, S. Suryaprabha Madam. Good evening to all, and also my hearty wishes to all the participants and also the teaching and non-teaching and my dear students, very good evening to all. So on this occasion, I would like to speak some few words. So from last 1 month itself, we are doing very well and making this program making as a grand success manner. So we are invite to all others in around the entire the South India, and also from other states like Tamil Nadu and Karnataka and Telangana. From different states, we got the different papers, and also this topic is a very present days. Now we are thinking about that everyone. So what is the future of the India? The future of the India is nothing but, so we should be uh, move in smooth manner. Without electrical vehicles, it is not possible, because of nowadays all the diesel and petrol, you know very well, the prices are going hike day to day wise. So without the electricity or electrical vehicle, it's very difficult to run the society. That's why on this point of view, so with the help of our sponsor society, that is ASCT and college and CBIT college management, so combinationally they are cooperate and done this event. So thank you for giving this opportunity on this occasion for ASCT members and our honorable chairman Dr. V. Jayachandra Reddy Sarkar. So thank you for all participants and also convener, head of the department, and teaching and non-teaching members. So thank you once again for making of this program is a grand success manner. Thank you one and all. Thank you.
Thank you, sir. Varprasad sir. Thank you for your valuable words. And I request this conference coordinator, convener, Dr. R. Saravanan Garu, to come on to the dais and to speak, to give some valuable suggestions. Sir, please.
Thank you, sir. Thank you, Praveen, sir. So good evening, all. It gives me immense to extend a very warm welcome to all. So on behalf of Chaitanya Bharati Institute of Technology, Predator, CBIT family delighted and honored to host the 2 days online national conference and the grant for organizing conference scheme on electric vehicle charging infrastructure, jointly organized by Chaitanya Bharati Institute of Technology and AICT Delhi. So, no. I didn't prepare it. This conference is principally designed to enhance the knowledge in electric vehicle and charging infrastructure. This conference enhances our technical skill in advancement of electric vehicle field. We successfully complete the session with all your sincere effort actually. So we are grateful our beloved chairman, Dr. V. Jayachandra Reddy, for the vision and the commitment towards staff and the students' professional development on CBIT. I take this opportunity to thank our respected principal, Dr. G. Srinivasal Reddy, for his hard work in his development CBIT. CBIT wants to offer thanks to our regarded chief guest, Dr. N. Stalin sir, and expert Dr. Stalin and K. Kadiravan sir. So, and also notable presenters I would express my sincere thanks to Honorable Chair Dr. S. Surya Prabha HOD and Mr. N. Varaprasad Coordinator, of course, Dr. S. Aslam Sir, Associate Professor, and our Mr. Y. Praveen Kumar Reddy Sir, Assistant Professor, and without our students, Sai and Mahesh team, so last 2 days, they put a lot of effort, and all other HODs and all supporting staff are to take part of this successful session. Also, I express my wishes to EEE final year students and their third year students. Thankful for great success this event. Thank you, sir. Thank you for your supporting for last 2 days for Kadravan and Sir Stalin, sir. Thank you, sir.
Thank you, sir. Thank you,
Welcome,
sir.
sir. Welcome.
And sir, I request our today's chief guest for this program, Dr. N. Stalin, sir, to speak about this conference. And moreover, Dr. N. Stalin, sir, and Dr. K. Kadrivan, sir, both are acting as external jury members for this conference. And sir, I would like to please invite Dr. N. Stalin Garu to speak about this conference. Thank you, sir.
Very good afternoon. Good afternoon, Dr. Kadrivan, sir.
Good afternoon. Good afternoon, sir. Good afternoon.
So this conference is excellently organized by the CBIT,
Yes, sir.
Chaitanya Bharati Institute of Technology. First of all, my special gratitude Dr. V. Jayachandra Reddy, sir, the chairman of Bharati Educational Society. What I emphasized in the inaugural function, definitely students has reached their perfection, and definitely they attained their fulfillment in the research, and they created some self-confident and innovative research. And also my special thanks to our patron, Dr. Srinivasulu Reddy, sir, principal of CBIT, and head of the department, Surya Prabha madam, and the convener R. Saravani. So co-convener Mr. N. Varaprasad. You all excellently organized this program, very functional in nature. I really appreciate it. And other things, from the starting of the first day, the n number of paper I gone through it. The day first, DC to DC converter used for charging the electrical vehicle. It was nicely presented. And somebody has given the electrical vehicle is whether it is right for me or not. They have given very good conclusions. And some of the obstacles for blind people. So one person has made a small kit, a working model, that is also appreciated one. And Dr. B. Kobe, charging vehicle with the electrical power, has given a brief introduction about that. And somebody has given the robot for identifying landmine explosion. That is also nice explanation. And some open charging protocol point has also explained about this charging with OCCP2 or 1.6, how it is helpful to the charging station. And electrical vehicle charging using PV system also they explained. That is also nice presentation. Somebody is explaining the contactless charging for electrical vehicle, and he has given 1 or 2 negative points about that. But it is also a nice presentation. And the final presentation in the first day, another person is explaining about contactless charging. And today when I observed 8 to 10 papers, it was nice presentation, especially for the dynamic management, location and dynamic management of electrical vehicle charging, and segmentation of EV charging infrastructure, and the Gray Wolf optimization, GOP. That is a very good explanation by your college faculty member. And somebody, other papers are only a theoretical research paper, electrical car modeling working, and electrical vehicle charging infrastructure, electrical vehicle battery infrastructure. These are all theoretically they've taken data and what would be the level 1, level 2, level 3 charging. So this was very nice presentation for all the presenters. So I really appreciate that all the presenters as well as the organizers, especially Dr. Saravanan sir, and the HOD, convener and co-conveners, and the HOD Madam, Dr. Surya Prabha, and the foremost head of the institute, Srinivas Reddy sir. Hats off you for your this type of conducting and giving this permission and also organizing with the help of the head only. So I really appreciate Dr. Srinivas Reddy sir, the principal, as well as Chaitendra Reddy sir, the chairman of the institute. Thank you. It is a very good organizing program. I really appreciate all because of now presently people are want to charge the fuel within 5 minutes. They have to do it with the diesel or petrol, right? But when you charge the electrical vehicle, it will take long time. So when you do it with a short time, feeling that it gives you a lot of emission to the atmosphere. Say an example, diesel and petrol, you can charge it within 5 to 2 minutes. You can fill up the petrol and go for driving. But when you charge the electrical energy, that will not give any pollution to the environment. But when you produce this electrical energy with a fuel like coal or any other fossil fuel, that will give you the maximum pollution to the environment. So nowadays we are the people are working towards how to minimize the greenhouse gases because of this only give more impact to the environment. Rise in temperature to the atmosphere, especially when we measure the air quality index, Delhi, Rajasthan, Kota, and Chennai. Chennai is somewhat less compared to other cities. Their air quality index rate will be more than 250. If it is a 250, see, one of my friend is position in YNCC, very higher position in YNCC. But because of the breathing problem, he was affected with the cancer. But he cannot tolerate. Within 6 months, he is going to die. The doctor said within 6 months, you are going to die. He cannot tolerate this news. He cannot able to accept the news because of all pollution. Because of you are living in the pollution environment, or you are indulging, you are getting all the disease yourself because of polluting more. So this has to be prevented by adopting this electrical vehicle usage and also by using renewable energy system. Definitely we will achieve this technology and we will come up with a successful run. So all the best to all the organizers, especially our chairman and the principal and HOD and conveners. Thank you. Thank you. Thank you, Kadiresan sir.
Thank you.
Thank you, Dr. Stein sir, for your words. So very outstanding, sir. You are almost all. You mean you touched each and every paper which you have judged, and just we got feedback from students also, some like participants. The way you are asking the questions and your practical exposure, your personal experiences towards EV, your passion. I think you are more passionate about EV. Thank you, sir. Definitely. Thank you. And I will request Dr. K. Kadiravan sir to speak about this conference. Thank you, sir.
Thank you, Praveen sir. It's my pleasure. I would like to express my gratitude to the chairman of CBIT, V. Jayachandra Reddy, director of CBIT, V. Lohit Reddy, principal of CBIT, Dr. Srinivas Reddy, special guest Dr. N. Stalin sir, and from University Trichy, head of the department Dr. S. Surya Prabha, ma'am, and convener Dr. R. Saravanan, co-convener Varprasad Reddy, coordinators and CBT staffs and students. First of all, this ACT sponsor today's national conference creates a very good awareness and on the EV modeling as well as the usage in extent to that EV setup. It creates a pollution-free transportation and environment across the nation. It cheers the everybody engineers of native CVIT as well as other presenters from various institutes and industries were made their presentation well. This conference creates awareness and knowledge sharing among us. Once again, my hearty wishes to CBIT family and crews. Thanks a lot.
Thank you, sir. Thank you to both
Have a
of
nice
you,
day.
and hope our association will be continuing for the further endeavors, sir. Thank you.
Thank you,
So,
sir. Thanks so much.
so just a small announcement to the participants, I mean authors. So all your papers are going to publish in a reputed journal named International Journal of Advanced Research and Innovation. So maybe it will take 10 to 15 days, and it is a reputed journal. And don't forget to fill the feedback form. and we have separately sent day 1 feedback form and day 2 feedback form. And also we are having a WhatsApp group for this conference by name NCEVI-2022 AICTE CBIT. So if you have any queries, you can reach to us either through mail or through WhatsApp or by phone also. And thank you all. And here we go for the final segment of this valedictory function for the vote of thanks. So I feel very honored and privileged to get this opportunity to propose a vote of thanks on this special auspicious occasion. I would like to thank all the honorable delegates and dignitaries who blessed us with their presence. On behalf of the organizing committee of this conference, I convey my deep regards and hearty thanks to our honorable chairman, Dr. V. Jayachandra Reddy Garu, for his extendable contribution and support to make this national level conference this much successful. And also, my special thanks to the director V. Lohit Reddy Garu for his gracious presence. And I'm also thankful to the principal, the patron for this conference, Dr. G. Srinivas Reddy Garu, who helped us in obtaining the necessary administrative approvals for organizing this event in our campus. So thank you, sir, for the support in all the possible manners you have given to make this conference in a grand manner. And I am also very much thankful to all the program advisory committee members, external jury members, and today's chief guest for this valedictory function, Dr. N. Stalin Garu, Dr. K. Kadiravan Garu, and also the internal jury member, the associate professor of CBIT, Dr. S. Aslam Garu, who acted as the internal jury member. So I am very much thankful to you, sir, for guiding these papers. And I would like to thank our beloved head of the department, Dr. S. Suryaprabha Madam Garu, for her constant help and guidance that radiated a source of energy within us. And my sincere thanks to Dr. R. Saravanan Sar Garu, the coordinator, the convener of NCEVI 2022. So without the main person behind this is for getting this conference live is the effort made by R. Saravanan Sar Garu. So thank you, sir, for your valuable effort. Without you, this conference cannot be possible. And I am very much thankful to all our head of the departments, teaching and non-teaching staff members, and especially our student coordinators, technical team, Sai, Mahesh, Shiva, Giri Sai, Kiran, Hema Vishweswarao, the students of final triple E and third triple E. And this program was meant on live in YouTube channel also. Since 2 days, we can watch in YouTube channel also. And before closing this, I feel proud and thank you for each and everyone for making this event a grand successful one. Thank you all. Thank you. Have a wonderful stay and all the best for future endeavors. Thank you, sir. Thank you.
Thank you. Thank you.
Sir Kadiravan sir, and Stalin sir, thank you sir, thank you so much for your valuable time for last 2 days.
Yes,
thank
sir.
you sir. I think you are from outside sir. Where are you sir now?
No, just background I have changed.
Background like that. It seems like you are in abroad actually.
Background I have changed.
Thank you sir. Thank you sir. Thank you so much. Kadiravan sir, thank you so much for you also. You spend valuable time. Thank you so much. I'll call you back. Okay?
Okay, fine.
And finally, the day has come where we have concluded our conference. I request all the participants to fill the feedback form where the information that you provide will be used to issue a certificate. The e-certificate and the proceedings of this paper will be sent to each and every participant's mail ID in a week or 2. So if you have any queries related to this, you may please contact Mr. Y. Praveen Kumar Reddy So the details of which are already given in the mails, individual mails sent to you. This was a great conference. So many of you have said to me, thank you for being so positive. Thank you so much. Have a good day.